स्टार्ट हो गया। आना चाहिए था, नहीं बारिश है। चल ये नहीं है, ये है ना। All right. Hi everyone. I had some issues with streaming, but I think now they are resolved now. Okay, if anyone can see me live, then let me know. Hi Abhishek. Okay, I'll wait for a minute or two for some people to join and then we'll start. Okay, seeing you after a long time. Yes, I haven't been live for like 6 months, I think. I used to do some uploading videos on Unacademy 6 months ago, but then I had some like prior commitments, so I couldn't make any more videos. But I think I'll be back now. I'll start streaming regularly for these Codeforces solutions and some other stuff as well. Okay, cool. Okay, let me check how many people are watching. Okay, it's 3 people. Okay. Rishabh, share on Discord channel. Yeah, okay, sure. Okay. Okay, I think the reach of my channel has really gone down because I can see only 4 people watching right now. So I hope this will get better with some time. Okay. So I'm gonna be solving Codeforces around 758 Div-1 plus Div-2, and we are going to do A, B, and C. Okay. Okay, cool. So I think I should start now. I think it will be like a 30-minute stream. Okay, and I'll just go through the solutions very fast. Okay. So given n, let's start with problem A. The problem says that given n, find an array a1 till an of integers such that all of the following conditions hold. Such that, okay, so we are supposed to, okay, I haven't shared my screen, I think. Okay, cool. Okay, cool. So this is the first problem, and given n for any array a1 to an of integers such that all of the following conditions hold, we want ai should be less than equal to 10 to the power 9 and greater than equal to 1. Okay, then a1 should be less than a2, less than a3, and so on. Okay, and the last condition is that for every I from 2 to n, ai isn't divisible by ai minus 1. Okay, so not very strict conditions. Okay, and we can easily find a solution for this. So basically, if you see that if we take integers from 2 to n plus 1, okay, we cannot take 1 because then if a1 is 1, then a2 will be divisible by a1, which is something that we are not supposed to do. Therefore, we'll start from 2 and print all the numbers from 2 to n plus 1. Okay, so yeah, that's all you have to do. I'll just show you my solution as well. So I just took from I equals to 2 till I less than equal to n plus 1 and printed all those numbers, and that's it. I think everybody was able to do that. We have around 10,000 summations for this problem. So it was a pretty easy problem, and the scoring was also like 250 only for this one. So it was supposed to be a very easy problem. Okay. Okay, let's move on to problem B now. Okay, it's an implementation problem, and okay, Aditya says, sir, please make consistent videos. Yes, I'll make consistent videos now. Like, I'll be consistent. Okay, we have a contest tomorrow as well. I will do that as well. Okay, anyways, let's move on to problem B now. You are given three integers n, a and b. Determine if there exists a permutation p1 till pn of integers from 1 to n such that there are exactly a integers I with I greater than equal to 2 and less than equal to n minus 1 such that pi minus 1 is less than pi and greater than pi plus 1. So basically what they're trying to say is that we need a number of local maximas, okay, and in the second one they're trying to say is that we need b number of local minimas, okay. That's all we have in this problem, okay, and we are supposed to find such a permutation which satisfies both these conditions and print it. If that is not possible, we just need to print -1. Okay, so this is more like an implementation problem, and I'll just show you my board now. Okay, so basically we are given an n, a and b. Okay, now a is the number of maximas and b is the number of minimas. Okay, so I'll just read out start with some examples. So if we have 4 1 1, which is the given example, okay, the answer for this is 1 3 2 4. As you can see, 2 is a minima here, as 2 is less than 3 and less than 4, okay, and we needed one minima only, and 3 is a maxima here because 3 is greater than 1 and greater than 2. Okay, 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 cool. So and we only wanted one maxima, so this is a valid solution. The next case is 6 1 2. Okay, and the solution for this, the given solution for this one is 4 2 3 1 5 and 6. Now if you see, this 2 is a minima here because 2 is less than 4 and less than 3. Okay, then this 1 is a minima here because 1 is less than 3 and less than 5. Okay, and this 3 is a maxima here because 3 is greater than 2 and greater than 1, and we needed one maxima, two minimums. Okay, so yeah, this is also again a valid solution. Okay, then we have 6 4 and 0. Now if you try to come up with any solution, nothing will work, and hence the answer for this is -1. Okay, Chakshu says, hey man, good evening. Good evening. I just wanted to ask, you are solving them or are you explaining your solution? I am explaining my solution, more like explaining my solution. Okay, the solution that I have submitted. Yeah, I'll be explaining the solution that I have submitted. Okay, okay, anyways, so how to do this? The very first thing that you need to notice in that is that the absolute difference between a and b should not be greater than 1. Okay, so absolute difference between a and b should be less than equal to 1. Okay, there are many ways to prove this. Okay, you can just try making some examples and you'll see that. Okay, so let's try this. So basically, let's say a is 2 and b is 0. Okay, the absolute difference between these two values is 2. Therefore, I can say that we won't ever find a solution. Let's try to find a solution for this. Let's say n is 5. Okay, now we need two local maximas. Okay, since we need maximas, we can say, let's say 5 is here and 4 is here. The rest three numbers will be here, 1 2 and 3. Now these are maximas, no problem, but if you see, this 2 becomes a minima here, and therefore it has two maximas and one minima, and there's no way we can actually make a case in which we only have two maximas and 0 minimas. You can try this with different examples as well, but you won't be able to find any. Okay, now how to solve that? So now that we know about this condition, okay, there are three cases: either a is equals to b, or a is equals to b minus 1, or a equals to b plus 1, right? These are the only three conditions that we can have. Let's try to find an answer for all the cases. Okay, I hope the solution till here is clear to everyone. If there is some issue with that, just let me know. Okay, so I'll just write down the three cases, the three ways how we can do this. Okay, so let's assume n is 8. Okay, let's assume n is 8. Okay, and assume a equals to 2 and b is equals to 2. Okay, if that is the case, or let's move this as well. Let's say n equals to 4, a equals to 1 and b equals to 1. Sorry, but please repeat the condition. Okay, so basically there are three conditions: a equals to b, a equals to b minus 1, and a equals to b plus 1. The reason for that is because we have found out that the absolute difference between a and b can not be greater than 1. Okay, yeah, that's it. Okay, so let's say n equals to 4 and a equals to 1 and b equals to 1. Okay, now if you see, so we need one local maxima and one local minima. Okay, now there are many solutions for this. The easiest solution that you can think of is 4 2 1 4 3. 1 is a local minima and 4 is a local maxima. Okay, let's say if a would have been 2, b would have been 2. Okay, now if you see, there are no more numbers left, therefore we cannot make this. Okay, let's try this with 6. If n is equals to 6, let's see how many values we can get. If we say 2 1 4 3 6 5, we see 1 is a minima here, 3 is a minima here, 4 is a maxima here, 6 is a maxima here, right? So we have a equals to 2, b equals to 2, and we have a solution. With this, we can also say that n should be, so basically, yeah, n should be greater than equal to a plus b plus 2, because these are the local maximas and minimas, and we need two more values in the sides to make this condition. Okay, so the minimum value of n should be a plus b plus 2. Is that correct and okay with everyone? Okay, now moving on. So these are the general, what do we say, like things that you had to notice in this problem. Okay, and then just come up with any way to make these three cases. Okay, so I'll just write a way for these, and then there are many ways to, what do we say, like write the solution of this one. Okay, so when a equals to b, the best way I personally could find was, we can say, like, let's say n is equals to 8. Okay, what we can do is, we can have the very starting numbers make this a equals to b. So let's say if a is equals to 1, b equals to 1. Okay, what we can do is, we can write 2 1 4 3, these are the first four numbers, and then we can write 8 7 6 5 in the start. If you see here, 1 is a minima here and 4 is a maxima here, and other than that there is no maxima or minima in this one. So this is the case when a equals to b. Okay, now let's move on to the different one when a equals to b minus 1. Okay, so basically when the number of minimas is greater than the number of maximas. Okay, so in this case what we can do is, so I'll again take a case when a equals to 2, sorry, a equals to 1 and b equals to 2. A solution for this would be, we can say 2 1 4 3, and then we can write rest of the numbers 5 6 7 and 8. So you can see 1 is a minima here, 4 is a maxima here, and sorry, 1 is a minima here and 3 is a minima here and 4 is a maxima here. So we have 2 minimas and 1 maxima. Okay, so this is the case when a is equals to b minus 1. And now coming on to the last case when a is equals to b plus 1. Basically the number of maximas is greater than the number of minimas. Okay, so in this one, what we can, so let's say a is equals to 2 now and b equals to 1. Okay, so for this one, the way we can write this is, we take the last four values. So we have 6 5 7 8, and then we have 1 2 3 4. You can see this is a minima here, this is a maxima here, and this is a maxima here. Okay, so these are the three cases and the three ways how we can solve this. Okay, now you can write the code in any manner. Okay, I'll just show you how I wrote the code. Okay, yeah, okay, cool. I'll just show you my code now. This is problem B, right? Okay. Okay, so this is the first case when a equals to b. Then this is the second case when a equals to b plus 1. Basically the number of maximas is greater than the number of minimas. And this is the last case when the number of maximas is less than the number of minimas. Okay, and before this I've written a condition that n should be greater than or equal to a plus b plus 2, because we have already established this one, that n should be greater than a plus b plus 2. So I've written this here, and the rest of the cases are minus 1. Okay, so more like an implementation problem, nothing much to think about. And I think like everybody is clear with this approach. You can take a screenshot of the code if you want, or you can just take it up from my profile. Okay, cool. Okay, let's move on to problem C, and I have a very interesting solution for problem C now. Like, my own solution is giving me a wrong answer. I don't know why it is giving me a wrong answer, but I looked at someone else's solution and it is a very interesting solution, and I don't think anyone has used that solution except that person. Okay. Okay, so the problem says that n players are playing a game. There are two different maps in the game. For each player, you know his strength on each map. When two players fight on a specific map, the player with highest strength on the map always wins. No two players have the same strength on the same map. So basically, we are given two maps, the first map and the second map. Okay, and in every map, no two players have the same strength. And if two players are supposed to fight, they pick a map. Someone is supposed to pick a map for them, and in that map, whoever has the highest strength wins. Okay. So you are the game master and want to organize a tournament. There will be a total of n-1 battles. While there is more than one player in the tournament, choose any map and any two remaining players to fight it. The player who loses will be eliminated from the tournament. Okay, so basically, in the end, exactly one player will remain and he's declared the winner of the tournament. For each player, determine if he can win the tournament. Okay, so I'll just share my board again and show you the examples. Okay, so what they're telling us is that we have a map 1 and we have a map 2. Okay, so let's pick the second case. Let's write indexes 1, 2, 3 and 4. Okay, and in map 1 the strength of player 1 is 11. In map 1 the strength of player 2 is 12. Okay, then 20, 21. Okay, and the other case values are 22, 44, 22, 11 and 30. Okay, so let's look at every player. Okay, let's look at player 1. Now in map 1 he has a strength of 11. Okay, in order to win in map 1 the value of another player in map 1 should be less than 11, but as you can see there is no other player. Okay, so what he does is he makes use of his map 2. He sees that I have a strength of 44 in map 2. So how about I see all the people who have less value than me in map 2. As you can see, all the three values are lesser than this. Therefore, we can say that there is a way in which player 1 can win. Okay, coming on to player 2. Now this player will say that I have a strength of 12 in map 1. So I can easily win player number 1. Right. The moment player 2 realizes, okay, let's do this. Okay, he knows that he can win player number 1. Okay, then he sees that player number 3 and 4 have greater strength in map 1. So he goes to map 2, sees that I have a value strength of 22, which is greater than 11 and 30. Therefore, I can win from player 3 and 4 in map 2 and from player 1 in map 1. Okay, though there was no need for looking at player 3 and 4 because player 2 could already see that he can win from player 1. Okay, since he can win from player 1, he can already say that since 1 was able to win from all the other people, therefore there must be a way in which player 2 can win from all the other people as well if he can win from player 1. That is the key here. So basically player 1 won all matches. Okay, now player 2 won from player 1, and since player 2 won from player 1, we can say that player 1 was able to beat 2, 3 and 4 in some way. Now since player 2 could beat 1, he can say that there is a way he can beat 3 and 4 as well. Okay, similarly, let's go to player 3 now. He has a strength of 20 in map 1 and he knows that he can easily beat player 2 and player 1. And he knows that player 2 and player 1 can have a way to win all the matches. Therefore, we can say that player 3 will also be able to win all the matches. And as you can also see, yeah, okay, cool. Then let's come to player 4. Similarly, we know that player 4 can win from player 3 2 and 1. Therefore, we can say that player 4 can also win all the matches. Okay, I hope this is clear to everyone. Okay, now let me just show you how we can do this. The approach that I'm going to share is a very unique approach, I would say, because I could see that everybody else is using DFS. I don't really know why they're using that. So I'll share a very simpler approach with you. Okay, and okay, let's rub this as well. Okay, let's say we have 8 players. We have map 1, we have map 2. Okay, let's say these values are 1, 2, 3, 4, 5, 6, 7, and 8. The other values are, okay, let's say 6, 8, 5, 7. Or let's say we have a 7 here and a 5 here. Sorry, 6 here. Okay, this won't work actually. Let's say we have a 6 here, 7 here. I think this will work. Yeah, okay, cool. And let's say these are 4, 3, 2, 1 or any other case. Okay, what I'm trying to say is that these 4 people will be able to win all the matches and these 4 people won't be able to win. How can we say that? Okay, let's look at the highest value in map 1, which is this 8. Okay, cool. So we can say that player 8 knows how to win all the matches because of this 8. Similarly, we can say that player 7 also knows how to win all the matches because of this 8, because this 8 is maximum in map 2. Now, we know that 7 was okay. Now, okay, cool. So basically we took out the highest value in this map and the highest value in this map. Okay. Now, let's look at the highest value in this map again, in map 1. This is the 7. We see that this 7 is actually player number 7 only, so nothing changes. We already have player 7 as a winner. Let's try to find out the next maximum value in this map. Okay, the next maximum value in map 2 is this 7. Now this 7 will say, I know that I have the second largest value. The largest value was player 8. Okay, or this will say that player 8 didn't have the second largest value. That means I can win from player 8. And if I can win from player 8, I can win from every other player, because player 8 will win from all the other players for me, and then I'll just go and match with player 8 and win. With this, we can say player 6 will also be able to win. Okay. Similarly, if we try to find out the third largest value in map 2, that is this 6. And this 6 will say that I'm bigger than this 5. Therefore, I can win from player 8. And since player 8 will be able to win from all the other players, I can make him win from all the other players first, and then I can match with him to win him. Okay. So we can say player 5 will also be able to win. Okay. Now, okay. This is more like the complete solution. Now, how to generalize this? Okay. First, is everyone able to understand this? This is a little complex, I would say. But if you are able to understand this, you will be very blown away with the approach. I was, at least. Okay. So basically, I'll just again tell you the idea, what the idea is. Okay. Okay, sir, please. Okay, bhai, please don't quite this. Okay, quit this time. Okay. Also start DP problem series from CFA app. Okay, I'll think about this. Shreyas was able to solve only 2. B was hard implementation, didn't got time to read. See, that's okay. B was a good question as well. So if you're able to solve 2, that's also nice. Neelu Gupta says yes, bhaiya. Okay, cool. Okay, so let me try to generalize this approach now. So we know, okay, basically alternatively we'll try to find out the maximum value in map 1 and the maximum value in map 2. Okay, so the maximum value in map 1 is of player 8. Okay, so I'll just number all these players: 1, 2, 3, 4, 5, 6, and these are players. Okay, now we know the maximum value is of player 8. So we know that player 8. Okay. Then from this map, we know that player 7 has the maximum value. Okay. Now, what is the next maximum value in player map 1? That is of player 7 again. Okay. Then again, what is the maximum value in map 2? The next maximum value, that is player 6. That is player 6. Now, this player 6 will say that either it would have been player 8 here. Okay, then we would have a complete set of 7, 8, and therefore there wouldn't be any other solution for this one. But since player 6 knows now that there is some value in map 2 which is of player 8 and I have a bigger value from that value in map 2, therefore I'll be able to win this game from player 8 if it comes to map 2. And since I can win from player 8, I can win from all the other players as well. Okay, now again we'll go to map 1 again and look for the next largest value, which is of the 6, which is player 6. So we have player 6 again here. Okay, now we move on to map 2 and look at the next value, which is this 6 from player 5. So it says player 5. Now player 5 will again say that either it would have been player 8 here, then we would have said that it is a closed set. But since I know that there is a value in map 2 under player 8 which is less than my value, therefore I can win from player 8. And since I can win from player 8, I can win from all the other players as well. Okay, so I have player 8 here as again. Now let's look at the next value in map 1, which is this 5 of player 5. So we have player 5 here. Okay, okay, cool. Then coming on to map 2 again, we see that the next value is this 5, which is of player 8. Player 8. Now we see that this is a complete set. There is no value left of any player in map 1 or map 2 which is not included in these two sets. And since there is no other value, we can say that there is no other value which might be greater in any map. Okay, so that is the complete logic. If you are not able to understand this, I would suggest you to go a little back, like 2 minutes back in the video, and try to understand this approach again, because I get it, like it's a little hard to figure out. I myself read it from a friend, and I'll show you the code as well, the person who wrote this. Okay, so let's go to friend standing. And Rishabh, shout out to Rishabh for this approach. Okay, I'll just show you the code, like how he did it. So basically what he did was, he has vector A and vector B. These vectors are nothing but map. Okay, and in these vectors, he have actually inserted the value and the index of the player. Okay, and then sorted these values. So basically this is nothing but A and this is B, but sorted. He is actually sorting this as well, like later on. Okay, so I'll just go with this code only then. Okay. Okay, so his A is actually okay, cool. So his A is actually 1 1 2 2 3 3 4 4 so on till 8 8, and B is actually 1 4 first. Okay, the reason is because map 2 has the smallest value as 1 and player 4. Okay, then the next value is 2 3, then the next value is 3 2, 3 2, next value is 4 1, then we have 5 8, and so on. Okay, so this is A and this is B. Okay, cool. Then after that, what he's doing is he's running a okay, so now he has a set A SA and a set SB. Okay, and now he's actually inserting the very last value from this A. Okay, so let me just write all these values: 5 5 6 6 7 7. Then okay, we have 2 3 here, 3 2 here, 4 1. Then we'll have 5 8, we'll have 6 5, 7 6, and 8 7. Okay, now we have SA and SB. Now we are actually inserting the very last values, indexes of the very last values from A and B. The index of last value in A is 8, so we have 8 here, and in B we have 7. Okay, that means 8 has the largest value in map 1, 7 has the largest value in map 2, and therefore we know that these two people will always be able to win. Okay, now let's remove these two values now. After this we have 7 7, that means the 7th player will be able to win. Okay, then in this we have the 6th player, so we write 6 here. That means 6 had a value which was greater than the value that 8 had, because 8 is not present in SB. Since it is not present, we can say that 6 had a value in map 2 which had a greater strength than player 8, and therefore he can win from player 8 and 8 will win all the other matches for him. Okay, let's remove these two values as well. Let's come on to this 6. We insert the 6 in this SA, then we move on to player B, this B, and we have 5 here, so we insert 5 here. Again, this 5 says that since, okay, either it would have been 8 here, let's say we would have received 8 here, then we could have said there are 3 values in SA, 3 values in SB, all the 3 values are similar to each other, therefore we have a complete set, hence there is no similar value in map A or smaller value in map A or map B which can beat any of these players. Okay, but since this 8 was 5 actually here, this 5 can say that I have a value greater than player 8 in map 2. Therefore, I'll use that value to win from player 8, and then player 8 will win all the other matches for me. Okay. Again, so we have 5 here, so we remove these two values as well. Then we have 5 in set A and 8 in set B. Now, if you see, we got this 8 back, and this set is exactly identical with this set. And therefore, we can say that this is a complete set and there is no other value which might be greater than in any of the maps from any of these players. And hence, there is no other winner possible. Okay. Okay. I hope the approach is clear to everyone. A little difficult to understand first. Now, I'll tell you like why we have these two ifs here, because the code is perfectly right without these ifs as well, but it is actually giving a time limit exceeded. Therefore, what this person did is he is actually removing all the values which are like, so basically when he got the 7, he removed the 7 from here and here. Then when he got the 6, he's removing the 6 from this and this. Then when he got this 5, he's removing this 5 and this 5. And still we have some values in this. But then in the end, when this 8 came, he removed this 8 and this 8. And he could see that both the sets are same. Therefore, we could break out of this loop. Okay. That is the reason why he's using this erase, so that these sets remain very small. Okay. And if these two sets are small, therefore the time will be less to search these values. Okay. Yeah, that's it for this problem as well. I can see many people like got system testing wrong in problem C. Okay, anyways, this is it for this contest. We have a contest tomorrow as well. Let me see it. It starts at 8:35 and it will end at 10:35. So I'll probably come live at 11 p.m. Okay, and I'll do a 45-minute session and absolve all the like first 3 or 4 problems, whichever I'm able to understand, in the next stream. Okay. So yeah, that's it. The idea of these streams is that I'll try to make these very fast and small so that you have all the solution in 30 or 45 minutes. Yeah. Okay. Anyways, thanks everyone for joining. I hope I'll have a better like watch list next time. I have 10 live people only watching me right now. That's okay. Okay, cool.